Hi, I'm Dr. Alyssa Runyon. Welcome to my Polyvagal Theory book club. We are going to go through chapter by chapter of the Polyvagal Theory book by Stephen Porges. I have decided to do this series of videos because I have a lot of people who are interested in the vagus nerve, and so the go-to textbook, the pioneer of vagus nerve work, is Stephen Porges and his book, The Polyvagal Theory. However, it is super heavy on the research, the medical jargon, the Latin, and to be honest, as a doctor, I kind of fall asleep reading it as well. Even though I am heavily invested in the vagus nerve as I treat it every single day in my practice with people. So let's go through the book as a series. And so this is going to be the first video in the series, and we're going to cover the introduction and chapter 1. So what I want you to do first is make a hot beverage, get cozy, set the atmosphere to activate your parasympathetic nervous system. And basically how you do that is getting into the receiving mode. Because if you've been going about your day or you're exercising right now, anything that is activating your sympathetic nervous system, your fight or flight, you are going to be closed down to this information. So if that's you right now, hit pause on this video and go create like a hygge atmosphere. So I have a apple cinnamon tea because it's December here in Canada and it's pretty cold outside. You can see I have a big sweater on, I'm cozy. I got my candles. I have my beautiful alabaster stone. Has a tea light on the inside, so it glows in this alabaster stone light. So anyway, hit pause on the video now and create your receiving mode atmosphere, and we'll see you back. Okay, so if you are ready to receive the introduction and chapter 1 of the Polyvagal Theory, let's get started. So I have my book here. I have been through this book several times. I've listened to it on audio, and I have basically deduced the entire book down to, I think it's like 21 pages of written notes. Now, keep in mind, I have taken notes. I've left some stuff out that's second nature to me. So if you need any clarification at all, feel free to leave a comment below. And while you're there, hit like and subscribe to my channel so that you don't miss the next chapter whenever we decide to go through it. Okay, so introduction. So if you have the book in front of you, this is page 1. So we're going through the preface and the foreword and all that. So introduction. Why is there a polyvagal theory? So we are going to start with, at the very bottom of the page, the very last sentence, we're going to skip down there, and it says, the sympathetic centric view has been translated into popular press and public consciousness as a cliche that a limited amount of stress is good and too much stress is bad. But what were the thresholds of stress necessary for health or illness? In addition, consistent with the sympathetic centric view, we all were taught that the stress-related sympathetic excitation had evolutionary origins in mammalian fight or flight behaviors. Thus, we were taught that the increased sympathetic tone to novelty and danger was a reflection of our evolutionary history. So what he's saying here in the introduction is that physiological, psychobiological, all of those research mechanisms and theories are surrounded by the sympathetic centric view of things, meaning we are in this state of rest until danger or something happens and we flip over into fight or flight. So that's basically for centuries how it was basically viewed as a response of the human nervous system. So it's not that you'll hear him say in the introduction that he's not uncomfortable with this opposite effect of looking at the sympathetic and parasympathetic nervous system as working in opposition of each other. He's not opposed to that. However, you'll see in a little bit, there are different, let's say, levels or hierarchies of the way our nervous system processes our environment. So let's move on now. Page 3. So this is getting into the beginning of the polyvagal theory in his career. Okay, so Stephen Porges did his master's in 1969. Whoa, that's a long time ago. I'm making this video at the tail end of 2001, so that's a long time to be researching the vagus nerve. Okay, so let's go through this, the second last paragraph on page 3. The roots of the polyvagal theory emerged while conducting research on heart rate correlates of attention for my master's thesis. And then he references the actual paper from 1969. In this study, I noted that when subjects focused their attention on the task demands, the beat-to-beat heart rate pattern stabilized. The publication of the master's thesis became the first quantitative description of heart rate variability. And I'm just going to shorten that to HRV so I don't have to say it every single time. Okay, so the publication of the master's thesis became the first quantitative description of HRV as a response variable sensitive to psychological manipulations. My dissertation followed this theme by testing the correlates between HRV and reaction time performance. So what they usually do, I couldn't find actually the full study to this on the interweb. So what they usually do is measure people's reaction times to auditory stimulus or visual stimulus. So they'll get people to hit a button every time they hear something, or hit a button every time they see like a blinking flashing light, something standardized, and then they measure the heart rate variability while they're waiting for the stimulus to happen and then when it happens to them. So the dissertation confirmed that greater reductions in HRV were associated with faster reaction times. Moreover, the study identified that individual differences in HRV predicted action time performance and the degree to which HRV was suppressed while attending. Throughout the following 40 years, although methodologies and research questions have changed, my laboratory research has continued to conduct studies monitoring heart rate and quantifying HRV. So the roots of the polyvagal theory is him noticing HRV decreased with increased reaction time. So the faster people were able to react to a stimulus, their HRV dropped. Now let's talk about HRV. Heart rate variability is the beat-to-beat changes in your heart. So we just think of the heart rate just beating and the rate. So we usually measure beats per minute. If you have a heart rate monitor or a Fitbit or something like that, you probably know your resting heart rate or your exercise exertion heart rate and what's healthy and what's not. However, HRV has been shown to be a much better variable to measure to get an idea of how healthy someone is overall. And what it does is it measures the difference, meaning when your heart beats, it's your sympathetic, your fight or flight. And when it relaxes to fill up with blood again, that's your parasympathetic or your vagus nerve, allowing the heart to relax. So there's actually a beat-to-beat difference. So a healthy heart rate variability will be higher. Now, the world average is somewhere around 55. If you imagine it on a scale of 0 to 100, you're never going to be 0 or you'd be dead, and you're never going to be 100 or you'd be dead as well. So you want to have a higher HRV, a parasympathetic dominance state. Now, do you think, just think about it for a second, do you think that your reaction time to a flashing light or something auditory happening, do you actually think that that would keep you in a rest and digest parasympathetic state? No. And so that's why they started to notice that a reduction in HRV during these tests was associated with faster reaction times. And what science has sort of coined is a sympathovagal balance. So this balance between the sympathetic nervous system and the vagus nerve, basically, and it has to be in balance. But what you'll see is there's a hierarchy and there's different branches of the vagus nerve. So we will get to that. Okay, so moving on. So this is the, we're going to move on to page 4 and 5. So the Vagal Paradox. The Vagal Paradox came when Stephen Porges started to publish research on HRV and the vagus nerve in general, and then he actually got a response from a neonatal, where is it here? A neonatologist. So this is in the last paragraph on page 5. September 1992. So he got a letter that stated, this doctor stated, that he had learned that high vagal tone was bad for newborns and that it could kill them. And he ended his letter to Dr. Porges by stating that perhaps too much of a good thing is bad. And that really, really perplexed Dr. Porges, because the whole reason for figuring out heart rate variability was to measure the autonomic nervous system and see whether people are healthy or not, and what makes a good, healthy nervous system. So he has doctors in the field telling him high HRV is not necessarily a good thing in their world. So he's kind of perplexed. So he called this the Vagal Paradox, trying to figure out, okay, in the lab, a high HRV is great. In real life, why is it not great? So if you flip over to page 6, he said, how could the vagal regulation of the heart be an index of resilience and health when it was represented as a high amplitude respiratory sinus arrhythmia, and an index of risk when it was represented of in bradycardia? So bradycardia, that is a slow heart rate, like abnormally slow heart rate. So he labeled this contradiction in our understanding of the vagus nerve as the vagal paradox. Now, if you just flip back to page 5, he says, in the early 1990s, I had not incorporated into my research perspective the 3 important points that led to the conceptualization of the polyvagal theory. So these 3 conceptualizations are, first, although I wrote about the importance of having a high vagal tone as a positive health index, I did not conceptualize autonomic reactions as being hierarchical. For example, I did not conceptualize the vagus as being inhibitory of the sympathetic regulation of the heart. So he didn't consider that the vagus nerve was acting on the sympathetic nervous system. Up until then, they kind of looked at it as a completely separate pathway, and it's either parasympathetic or it's sympathetic. It can't be both. Now, the second is, he says, I had no understanding of how the neural regulation of the autonomic nervous system changed during evolution, and how these changes would be related to adaptive physiological and behavioral functions in mammals. So he's saying, I had no understanding how this autonomic nervous system would be related to behavior, basically. It's like, you kind of look at it as like, what are the attachments? Okay, we want to speed up or slow down heart rate. Like, we want to survive, we want to thrive, we want to grow, or we want to hide from danger. That was basically what they deduced life down to. But, and we'll talk about this later in the book, it touches like over and over again on the difference between mammals and reptiles. So we're not going to go there quite yet. But what he's saying is that he never considered behavior to be sort of a function of the autonomic nervous system. Autonomic means automatic. We just kind of thought that, well, it was the autonomic nervous system. It's programmed for survival and that's it. But you'll see this book makes the case, and this research makes the case for behavior affecting our life. Okay, and the last thing that led to the conceptualization of the polyvagal theory is that he knew, I'll just read it. Although I knew that vagal pathways originated from two brainstem nuclei, I did not think too much about their relative functions. So when you do a cross-section through the brainstem, you'll find that the vagus nerve actually originates from the dorsal motor nucleus and the nucleus ambiguous. Now, those are huge themes throughout this entire book. We will get further into them. I think we touch on them in chapter 1 coming up. But he didn't really consider right away. He knew, he must have saw, like they must have been doing like anatomical cadaver research, dissections. So at his time doing his polyvagal, his vagus nerve research, they knew anatomically that the vagus nerve originated from two different nuclei, but they didn't really think that, they didn't really consider that it would make the vagus nerve function in different ways by having those two originating nuclei, if that makes sense. And if it doesn't make sense, just hang tight. We're going to talk about them in the first chapter, actually. So I think that is it for the introduction. Yeah, and then he just kind of summarizes what each of the upcoming chapters is about. Okay, so Part 1, Theoretical Principles. Chapter 1, Neuroception, a subconscious system for detecting threat and safety. So I'm going to go to my notes first so we don't get lost in every single page of this dense book. Okay, so neuroception is a neurobiological response to situations that is deep in our autonomic system. It's a system for detecting threat versus safety. So what that means is, if it's automatic, it means that we can't control it, meaning it's not a conscious thing that you think about. Your neuroception means that it's happening at every minute of every day without your cortex getting involved, the analytical part of your mind. So whether you know it or not, your nervous system is constantly scanning both your external and your internal environment for safety and danger. So I'm going to jump down to the polyvagal theory neuroanatomically links the heart, the head, and the face. So this is described in 3 stages of the autonomic nervous system development. Okay, so first we have our immobilization system, and this comes from the dorsal motor nucleus. So let's skip to page 16. Okay, so on page 16, you're going to see the breakdown of the 3 developmental stages. So first we have, and when he's talking about developmental, he's talking about the evolution of the development of our nervous system. So the oldest part of our autonomic nervous system is the immobilization aspect of it. Okay, so this comes from the dorsal motor nucleus. So points are feigning death, behavioral shutdown, the most primitive component shared with most vertebrates. It's dependent on the oldest branch of the vagus nerve, unmyelinated portion originating in the area of the brainstem called the dorsal motor nucleus of vagus. So, dorsal motor nucleus of vagus is going to be a nuclei on both sides of the brainstem. You're always going to have a left and a right here. So imagine you have two vagus nerves, a left and a right vagus nerve. Those vagus nerves are going to have branch attachments to each. So like left is going to have an attachment to dorsal motor nucleus. Right is going to have attachment to dorsal motor nucleus. And then you'll see it'll have another attachment to nucleus ambiguous. Okay, so the next system. Let's go back to immobilization. When do we need this? We need immobilization to shut down and conserve. So a great example of this in modern times is domestic violence. So when you have someone who is being physically abused and it's been going on for a very long time, they initially will be stressed about it and have that fight or flight reaction to it. And they might try and get away. And we often wonder, why the heck do people stay in these awful, awful relationships? Well, it's actually an autonomic nervous system thing. So when your nervous system detects that your initial response was not effective. So let's say you tried to run away from the violence when it was happening to you, and then you got dragged back into it, or you got beaten down for speaking up. Anything that gets denied when your sympathetic nervous system reacts, you're going to immobilize. So your brain basically looks at it as, well, that didn't work. Fight or flight. We tried to fight the danger off. We tried to run away. It didn't work. So now we are going to immobilize. We're going to go into our shell and we're going to hide out and conserve energy because we know that death is slowly approaching. And so the idea is that you'll just prolong your life by conserving calories, basically. So it's at a really sad point when your nervous system finally gives up and says, we're probably going to die. Let's just immobilize. Now, a less intense example is procrastination, or that, what do people call it nowadays? Decision analysis paralysis. That's what it is. Analysis paralysis is when, in modern times, when you have so many decisions that you have to make, so many options, and you just can't make a decision, you procrastinate and you go into a paralysis. So you first switch into fight or flight, and it's like, oh my gosh, how do I choose what to pick here? And then you go into immobilization, analysis paralysis. But there's no hope in getting out of this. I can't make a decision. So you just hide in your little shell. And yeah, like I said, procrastination is kind of the same thing. That's an immobilization thing. So this is, you'll hear him say phylogenetically a lot throughout this book. So phylogenetically is sort of how we have evolved from reptiles to mammals, and how our nervous system has adapted and how our genetics have adapted to come up with new parts and pathways of our bodies to suit our environments. Okay, second oldest part of the developing autonomic nervous system is our mobilization system. Now, this is the opposite of the vagus nerve, remember. This is the sympathetic chain. So you'll see number 2, mobilization, fight or flight behaviors, dependent on the functioning of the sympathetic nervous system, a system associated with increasing metabolic activity and increasing cardiac output. For example, faster heart rate, greater ability of the heart to contract. So this is literally about having a fast reaction time, being able to mobilize blood to the arms and legs if you have to run away or you have to fight. So that is literally The only job of the sympathetic chain is to increase cardiac output, meaning putting more blood out there. And the way they do that, if you ever took physiology, cardiac output is stroke volume times heart rate. So the number of times you're pumping blood out, and the contractility, meaning how hard you can contract with each pulse. So each pulse is going to get stronger and you're going to do it more often. That's going to increase your cardiac output, and that is the sole purpose and responsibility of the sympathetic nervous system. Okay, now the social communication number 3, or social engagement. So this is basically the nuts and bolts of the polyvagal theory. This is the branch of the vagus nerve that took the research world from a sympathetic based model to now considering, okay, it is a nerve and it is the parasympathetic nervous system, but it's much, much more than that. So we're talking, life isn't just about survival anymore. It's about thriving. And how do we thrive? We socially engage. So, number 3, facial expression, vocalization, and listening. The social communication and social engagement system is dependent on the myelinated vagus, which originates in the area of the brainstem known as the nucleus ambiguus. Remember I said we were going to come back to that? The myelinated vagus fosters calm behavioral states by inhibiting the influence of the sympathetic nervous system on the heart. So if you've ever heard of the vagal brake, this is what he's talking about. This is sort of like a little tidbit in chapter 1 of what we're later going to talk about with the vagal brake. I believe there's a whole chapter on it. Okay, so let's go back to the social engagement system. So the newest branch of the autonomic nervous system. When our nervous system detects our environment as safe, I'm going to tell you the different facial features. And these can be found on page 15 if you actually want to see it written. So when the environment is safe, what do? We make eye contact. We have more appealing vocal sounds, pitches, and rhythm. We have nice facial expressions. And our middle ear muscles are modulated to distinguish the human voice from background noise. Now, have you ever had a conversation with someone that they're not making eye contact with you? And you say something and they're kind of like, what? Sorry, say it again. Or, if they're talking at you and let's say they're talking like this and they're like really excited and you're like in this calm state and someone starts talking to you like that, how receptive are you going to be? So all of those things, not making eye contact, having a really weird out of rhythm voice, and then someone not being able to hear your voice and separate it from background noise, those are all examples of when you are knocked out of the parasympathetic state. So the reason this is important is because when you are in a fight or flight sympathetic state, okay, you're running from danger or you're hiding so danger doesn't come and get you. Do you think it is absolutely necessary for you to smile back at another human being? Do you think it's necessary to make eye contact? Do you think it's necessary to hear the different fluctuations in the sort of mid-range of the vocal cords? The answer is no. When you are in a sympathetic state, you need to, the ear needs to change its shape so that you're only receiving the super high end, so like screams or squeals, anything that signifies danger. And then you need to hear those low vibrations. So Just imagine, like I'm thinking animal kingdom. If something is coming to hunt you, it's going to be bigger than you. Its voice is going to vibrate at a lower frequency, and you need to be able to hear those thunders. It reminds me of Jurassic Park when, they're looking at the water vibration, the ripples, and it's like, doom, doom, doom. When you're scared, you only notice the high pitches and the low, low frequencies. Everywhere in between is reserved for those subtle nuances where you can socially engage with someone and you can pick up on those nuances of like a wink or a smile. Like imagine your loved one smiles at you, but they don't say anything. Like, don't you get a warm, fuzzy feeling? They don't have to say anything. So that's another example of your neuroception. And depending on what state you are in with your autonomic nervous system, that's actually going to basically skew the information you're receiving. And then another cool thing is you can use your cortex, your analytical mind, to override what your neuroception is telling you. So we're going to sort of jump back and forth. I'm going to go back to the beginning of this chapter. Neuroception means that cognitively, people can feel fine, but their body can fail them. So that's exactly what I was just talking about with overriding it. So a really great common example of this is stage fright. So imagine you go on a stage to give a speech and you are paralyzed in fear. You talk like this because you are just trying to get through the lines on the screen, and you don't waste your energy on going up and down. You won't get your message across. In fact, you'll evoke fear in your audience, basically, if you're talking like that. So that's when it's funny, actually, just sidetrack. It's funny how these like kind of old wives' tales and like random little pieces of advice that we've given other human beings throughout history. It's kind of interesting how once you start learning this, all these little pieces of advice, we wonder where they came from and why they're such good pieces of advice, but they're basically all based on biology and how we operate. So great example of this. What do people tell you when you're nervous before you go on stage? They tell you to take a deep breath. What does a deep breath do? Activates your vagus nerve, activates your parasympathetic nervous system. So when you're giving a speech and you have stage fright and you're like, ugh, you usually forget what you were doing, right? You talk in a monotone because there's no like safety in vibrating your vocal cords at different aspects. So that's when our nervous system can actually betray us. And that's a word they use in the book, is betray. It's kind of harsh, but anyway, stage fright is a prime example of this, where your environment is actually pretty safe, right? If you're on stage giving a speech that people actually care about and have come to see you give it, you're probably not going to be in danger. However, if you have a faulty neuroceptive feedback, your body, your nervous system is telling your brain that this is danger. So the way you can override that is, again, deep breathing. All right. So normally children's cognitive awareness of risk matches their gut response to danger. So this is when children are born. So we talk about, the book talks about myelination versus unmyelinated. So when things are myelinated, imagine an electrical conducting wire and it's insulated. So that, if you don't know anything about electricity, when electricity is insulated, it makes the conduction speed faster. So that's what myelination is in our nerves. It is a fatty coating around the axons of our nerves to make that nervous signal travel faster. So the unmyelinated portions of our vagus nerve at birth are the nerves that go to our arms and legs. And we know this because when you look at a baby, they cannot run away from danger. They cannot fight. They're not coordinated. Their limbs are all over the place. They're, spastic. They have some reflexes, but essentially they can't run away from anything. However, the myelinated portions they're born myelinated, which means they're born fully insulated. They're quick. Those are the cortical bulbar tracts. So just to backtrack, cortical spinal tracts go to the arms and legs. So this is our cortex telling the nerves going to our hands to move, the nerves going to our legs to move. Cortical bulbar tracts are going from cortex to cranial nerves. And bulbar, I'll link a picture in here. Bulbar, it's the medulla oblongata in the brainstem, and it's literally, bulbar is just Latin for like a bulb appearance, like a light bulb. So this is where the dorsal motor nucleus of vagus and the nucleus ambiguus are. So you can picture it as like a light bulb in the brainstem. So those tracts that go from cortex to top of the vagus nerve, they're already myelinated. So you are born with the ability to, the full ability to detect facial expression in people. And a lot of mothers report to me that their babies are, let's say, reactive to certain musics. That's why you can sing a lullaby. That's why you can rock your baby. We're going to go over all these attachments later in the Polyvagal Theory book, but essentially all the branches of the cranial nerves, those cortical bulbar pathways, are fully developed at birth. We don't have to develop them anymore. So your baby, even in the time that it's still a fetus in the womb, it is fully present with those 5 senses to the world around it. So think of the implications of that. We're talking not only birth trauma, but fetal trauma. So the emotions and the feelings and the sounds that are happening. Have you seen that research where you can put a set of headphones on your belly and play classical music and babies are more calm? That's because their cortical bulbar tracts are fully developed when they're born. So yeah, basically on the flip side, on the negative side of that, you actually can start experiencing and storing trauma before you're born. So tons of developmental implications for that. And we won't go into that in this video or chapter 1. That's a totally separate video. But yeah, so let's move on. Let's make sure okay, so let's go back to the environment. When the environment is not safe, what you'll notice in people, and this is kind of cool if you look around at your environment when you meet people, you're looking for asymmetry because of course we have a left and a right vagus nerve, and they're linked to the cranial nerves left and right as well, that control the face, that control chewing, that control swallowing, that control our vocal cords. So you're looking for symmetry. When someone thinks that their environment is not safe, they get eyelid drooping, their voice loses appeal, which we already talked about. Positive facial expressions dwindle. Have you ever talked to someone that is just like this and they have no facial expression to your story? Yeah. The awareness of sound of the human voice becomes less acute. So this is the person again that's like, what? Say that again. They cannot distinguish your voice from background sounds because they're not in a social engagement state in their nervous system. And then sensitivity to other social engagement behaviors decreases. So have you ever met anyone who is horrible at picking up on body language? Probably more so to do with their state of their autonomic nervous system, where they're at in terms of on the scale of immobilization, mobilization, and social engagement. If they're not over here in social engagement mode, they're definitely going to be horrible at picking up on your social engagement behaviors. So it might not necessarily be something that people are bound to. Like if someone says, oh no, I'm horrible at reading body language. You're probably not horrible at it. You just are not setting the intention of bringing yourself into that social engagement state before you actually social engage. That makes sense? Okay. Now let's go to page. So we're ending off the introduction chapter with we're ending it with the Romanian orphanage study. However, I just want to go to page 17. Just a quick little note on neuroception and mental health disorders. So you'll see that subheading on page 17. And I've just highlighted some of the bullet points. So from a theoretical perspective, faulty neuroception, that is an inability to detect accurately whether the environment is safe or if another person is trustworthy, might lie at the root of several psychiatric disorders. So let's just think here. He gives 3 examples of psychiatric disorders. Areas of the temporal cortex that are assumed to inhibit, so, put the brake on fight, flight, or freeze reactions. They found that they're not activated in people with autism, schizophrenia, and others that have problems with social engagement. So basically, again, you'll learn about this more in depth in other chapters, but when your vagus nerve system is activated and you're socially engaged, your vagus nerve actually inhibits your fight or flight. And that's what keeps you in your seat and listening to the person's story and having a beer with them and just chilling. You can't be in fight or flight and listen to a story and interact with someone. So what research has shown is that people with autism and schizophrenia, the areas of their brain that inhibit fight or flight, they actually don't light up in studies. So these people don't have the ability to socially engage because they're always in fight or flight or freeze. Does that make sense? Okay, individuals with a second bullet, individuals with anxiety disorders and depression. They have compromised social behavior, difficulties in regulating heart rate, as reflected in measures of vagal control on the heart and reduced facial expressiveness. So again, we've already talked about this. If you have anxiety, you're going to be talking in a monotone, you're going to be talking fast, which is going to elevate your heart rate, which is going to send you into fight or flight, and you're not going to be receptive to the people around you. No one's going to want to engage with someone who is like manic, right? We can tell on a neurophysiological level not to engage with that person because that's danger. Now, this is kind of where it gets sad, but interesting. And this is going to go to the Romanian orphanage study. Maltreated and institutionalized children with reactive attachment disorder tend to be either inhibited or uninhibited. So either emotionally withdrawn and unresponsive or indiscriminate in their attachment behavior. Okay, so moving on to the Romanian orphanage study. So this is the rest of page 17 and all into 18, but I've summarized it here in my little booklet. So Smyk et al. In 2002, they went to a Romanian orphanage and they did a study where they split orphans and caregivers into 2 groups. So group 1, there was 30 infants and 20 caregivers on 3 rotating shifts, right? Days, afternoons, midnights. 20 caregivers for 30 children. Okay. Second group, they had only 10 children and 4 caregivers. So that ratio is much higher. And it was the same 4 caregivers all the time, round the clock. Now, the conclusion was the more caregivers that these children were exposed to, the higher incidence of reactive attachment disorder. So, and in some instances, the children in group 2, which remember it was only 10 children with 4 round-the-clock caregivers that were consistent, they had the same indices, certain measurements as non-institutionalized children. So just children outside of the study, children who are raised in loving families by their biological parents. The markers of these children in group 2, which was the 10 children and 4 caregivers, were very similar to non-institutionalized children. So it just makes a case for babies need consistency. Their nervous systems are already programmed at birth to know your voice, know your smile, know your energy, basically. And when they don't have that consistency of that caregiver, when it's a new person coming at them all the time, and that part of their nervous system is already developed, they're going like, okay, where did that person go? Now we have a new person. This is dangerous. So we're setting our children up for failure when we don't have that consistency and that loving, caregiving nature and meeting their needs. So, in summary, page 19, conclusion. I'm just going to skip to, it's like the 4th sentence. These neural circuits provide physiological mechanisms that reflexively organize mobilization or immobilization behaviors before we are consciously aware of what's happening. So again, he's talking about neuroception here. Before we are cognitively, consciously aware of what is happening. When, on the other hand, neuroception tells us that our environment is safe and that the people in this environment are trustworthy, our mechanisms of defense are disabled. Again, he's saying the default state is fight or flight, and that we now, as human beings, as evolved mammals, we have the ability to put the brakes on that fight or flight system and that immobilization system. We can then behave in ways that encourage social engagement and positive attachment. And we talked about that, right? We cannot socially engage when we feel unsafe. And then moving down to one of the last sentences, how does this help us? We can alter the caregiving environment so that it will appear to be safe. Safer for children and less likely to evoke mobilization or immobilization responses. We can also intervene directly with children, exercising the neural regulation of brainstem structures, stimulating the neural regulation of social engagement system, and encouraging positive social behavior. So he's saying that with this, how does the polyvagal theory help us? How does knowing our phylogenetic reptilian to mammal development of the autonomic nervous system, why do we care about this information? Well, it's because we know that the safety of our environment when we are infants dictates our psychological and mental health later in life, and that we can come up with ways of manipulating our environment for these infants to make them feel safe, and that will encourage social behavior. So that is it for the introduction and chapter 1 on neuroception. So if you have any questions or you think I skipped over anything important that you need clarity on, please let me know in the comments. And again, make sure you like this video, make sure you subscribe to my channel so that you don't miss the next chapter. And that is chapter 2, Orienting in a Defensive World, Mammalian Modifications of Our Evolutionary Heritage. You don't want to miss that one. Now, if you're interested in more of my work, I do vagus nerve treatments in my office, and I actually monitor HRV before, during, and after the treatment to make sure that people are not only increasing their HRV during treatment, but each treatment, their HRV is getting higher and higher throughout their lives. So it's been a very impactful treatment on people, and it basically is recalibrating their nervous system from being in an immobilized or fight or flight state, and it's pushing them into that social engagement state, that ventral vagus, nucleus ambiguous. This might not make sense to you yet if you haven't been through the book, but we will get there, I promise. So I hope you enjoyed this video as an introduction to the vagus nerve and the theories behind it, Dr. Stephen Porges' work. Again, my name is Dr. Alyssa Runyon. I am here to break this book down for you, and I'm really excited. If you want to know more about reprogramming those infant neural pathways that we talked about for safety, you can visit www.reset3.ca. That is my program for reprogramming pain and behavioral patterns associated with your mind, your body, and your biofield. All right, have a great day. I'll see you in chapter 2.